All right, in this explainer, we're jumping straight into the deep end of AI security. We're not talking about your everyday hacks here. We're going to be exploring the really sophisticated, multi-stage attack techniques that are targeting today's most advanced AI systems. So let's get right into it. First up, a really important note for everyone watching. This is part 4 of a 5-part tutorial from Virtualization Options LLC, and it is strictly for educational purposes. The full course document, which is in PDF format, has way more detail than we can possibly cover here, so I absolutely recommend you check that out for the deep dive.
We really have to move beyond thinking about simple one-off attacks. The adversaries we're dealing with now are strategic. They think in long-term campaigns, where every single move informs the next one. Seriously, they're playing chess, not checkers.
And our first technique really shows what I'm talking about. We're going to look at an approach where attackers aren't just firing off random questions. No, they are learning from the AI's own answers to make their next queries exponentially more powerful.
It's called the iterative learning attack, and the whole idea here is to create a feedback loop with the AI. Every single response from the model, even if it's just a tiny partial leak of what we call PII, or personally identifiable information, becomes fresh intel to build an even better, more targeted attack for the next round.
So, how's it actually work? Well, it's this methodical 4-step process. First up is probing. Attackers just send out these broad queries, kind of fishing for any little fragment of personal data. Then comes analysis, where they take those fragments and figure out how to weaponize them. In the refinement stage, let's say they found part of an email. The very next query is designed specifically to get the rest of it. And finally, acceleration. They use that now complete piece of data to zero in on related info, like a phone number or an address. It just snowballs.
And the result of this whole chess-like strategy? It's pretty stunning. Research shows this iterative method gets a 5-fold increase in the rate of PII extraction compared to just asking random disconnected questions. A 5-phi improvement. That means they can steal sensitive data 5 times faster, which is an absolute game changer in the world of AI security.
Okay, next up, we're going to shift from a highly technical feedback loop to something that feels a lot more like psychological warfare. This is all about socially engineering the AI itself, using its own helpful nature against it.
We're talking about prompt injection. Here, the attacker cleverly embeds malicious instructions inside what looks like a totally normal user prompt. And because these models are built to follow instructions and be helpful, they can actually be tricked into ignoring their own safety rules. It's wild. The AI's greatest strength, following complex commands, becomes its biggest vulnerability.
So let's look at how this is actually done. An attacker might use a prompt like ignore previous instructions or they'll disguise a malicious request as some kind of legitimate debugging task, like asking to see the system prompt. It's a really clever manipulation of language that's designed to completely sidestep the AI's built-in guardrails. And believe me, this isn't just theory. In one real-world breach, attackers use these exact techniques to systematically pull out approximately 3,500 internal corporate documents from a public-facing AI. Just think about that for a second. Thousands of sensitive files, everything from contracts to internal strategy memos, all stolen just by tricking an AI with some cleverly worded sentences. Okay, now we're really escalating. The next class of attacks goes way beyond just pulling data from the model. These techniques target the system itself, the model's architecture, and the infrastructure it's running on. We're talking about cloning the AI's brain and literally stealing data from other people's sessions. So these systemic exploits basically fall into 2 main buckets. On one side, you've got shadow models. The goal here is to create a functional clone of the AI. We're talking pure intellectual property theft. On the other side, you have cross-session leakage, which is all about exploiting flaws in the system to grab data from other people who are using the AI at the same time. 2 very different goals, 2 very, very different threats. Let's focus on that first threat, the shadow model, because it is a complete mind-bender. What if an attacker could steal your multi-million-dollar AI model? Its very logic, its secret sauce, without ever seeing a single line of code or any of its training data. Well, that's exactly what a shadow model attack does. As you can see, attackers start by just collecting a massive amount of data, querying the target model thousands, even hundreds of thousands of times. Then they use all that data to train their own model to behave in the exact same way. Finally, they validate their clone to make sure it's a perfect copy. It's basically reverse engineering a brain just by asking it a ton of questions. And the economics behind this are just staggering. An attacker might need, say, 500,000 API calls. But with that, they can create a clone that's over 90% identical in how it behaves for an estimated cost of just $15,000. That is a shockingly low price to steal what could be millions of dollars in R&D.
So we've seen these powerful techniques on their own, but how do adversaries actually combine them in the real world? Let's walk through a sophisticated, incredibly patient, 9-month campaign that targeted a financial AI system.
This is that chess, not checkers idea in action. They start slow, spending the first month just on reconnaissance. For months, they probe. By months 4 and 5, they use a clever technique to confirm that specific high-value targets are clients. It's not until month 8 that they launch their massive extraction campaign. And the final checkmate, in month 9, using all that stolen data to train a shadow model and clone the company's core IP. It is a masterclass in patient, methodical exploitation.
All right, finally, let's look at what might be the next frontier of AI attacks. So far, we've focused on stealing data that's already in the model. But what if attackers could plant secrets inside the AI while it's being trained? This is what's known as poisoning the well. The concept is called data poisoning. Here, adversaries find a way to inject their own malicious data into the model's training set. This data could contain a hidden backdoor, or it could be a secret, like a password or an API key, that the model is forced to memorize. The AI basically becomes an unwitting accomplice, holding on to a secret that the attacker can come back for at any time.
And this idea is perfectly captured by the concept of the AI becoming a sleeper agent. It just operates normally, day in and day out, until the attacker uses a specific trigger phrase, a phrase they planted in the poison data, to activate it and reveal the secret it was forced to memorize. And all of this leaves us with a truly challenging question. From iterative extraction and prompt injection to model cloning and data poisoning, all these advanced attacks target the very fabric of how AI learns and operates. So, if an AI's memory can be so thoroughly manipulated, corrupted, and exploited, what can we truly trust? That, right there, is the fundamental challenge for the future of AI security.